Hello, learners, and welcome to Chapter 8, where we get to study all about joints. Now, joints are where bones meet, and they're the reason why a rigid skeleton can move. So let's go ahead and see how we're going to start organizing our understanding of joints. First, we're going to get a brief introduction to joints themselves, and then we're going to classify joints based on their function and their structure. So first, we're going to focus on the functional classes like synarthroses, amphiarthroses, and diarthroses. And then we're going to realize that some joints, like fibrous joints, cartilaginous joints, and synovial joints, all fall into those functional categories, okay? So for example, fibrous joints, as you can see, can be synarthroses or amphiarthroses. Cartilaginous joints can be both as well. And diarthroses are going to specifically be with synovial joints that we see. We're going to go into detail about what each of these pieces mean as we go along. Then we're going to get into the movement of synovial joints and types of synovial joints. Okay, so we see some types here, but we're going to get into the movement of them. And then finally, we'll talk about disorder of joints. You know, the human skeleton has that 200 plus bones. We always say 206, and almost all of them are in contact with other skeletal elements at joints. Okay, so that's what we know for sure. Now, joints can also be called articulations. When we saw in Chapter 7 for the skeletal system, there's a lot about, oh, this bone articulates with this one. That means it's going to form a joint with that other bone. So you can also call it articulation or arthrosis. And anytime you see that arth, you're going to be looking for your understanding of a joint, okay? So again, it's the contact point between two or more bones or a bone and a tooth. And the reason why bone and teeth are not the same is because they're not made the same. Their structure is not the same. They don't have the same composition, so just keep that in mind. Another thing we'll see is that a lot of joints can also have cartilage. We're talking specifically hyaline cartilage or fibrocartilage, ligaments, those bands of connective tissue that connect bone to another bone, tendons, which are going to connect muscle to bone, and then muscles themselves. So they all can help form stability of joints. There are two essential functions. One is going to facilitate skeletal mobility. We said it helps the skeleton move by structural stability. Now here's the catch. These are both inversely related. So if you find a joint that allows for a lot of mobility, like say our shoulder joint or our hip joint, it's going to provide less stability. So that means they're probably going to be more prone to injury. Okay, and of course, there's different things like cartilage, ligaments, tendons, and muscles that can help stabilize them a little bit better if they lose stability. And then oppositely, if you find a joint that's very, very stable because of the strength of maybe the fibers that are there, then it's going to be less mobile, almost have no movement. Okay, so you can say the greater the range of motion, the less stable the joint is, and vice versa. So let's get into a couple examples. We have our finger joints, our shoulder joints, and our bone to tooth connection. Okay, so in the finger joints, you'll notice that you have joints here in between the phalanges of the fingers, and that's what they're kind of pointing out to. And so those are just going to be simple joints in between the bones. Where the shoulder joint, yes, we definitely see some cartilage here. We definitely see a tendon. We definitely see a muscle. And of course, we also see some ligaments. Okay, and I'm just putting L for each of those. So as you can see, it's not just going to be one little piece of that shoulder joint. Now the bone to tooth, we do see our jawbone. Because we're talking about teeth, it could be upper or lower jaw. A lot of times when you're thinking of upper and lower jaw, you know that the mandible has the ability to move. Just keep that in mind. And then we also see that the tooth is there. So let's talk about it. When you're thinking of a tooth, how much motion does your tooth have? It has a lot of less motion, right? And so that means your tooth and your bone to tooth connection should be more stable. Now, teeth, of course, have to have some type of level of movement when it comes to chewing or mastication. And so we'll see that as we talk about the foci as we go along. Now, the shoulder joint is going to have a lot more movement, you can see. But that also means they're going to be less stable and are injury prone. So what do? You see there's a lot of muscles, tendons, cartilage, and ligaments surrounding that joint to help support it. How do we organize ourselves? Well, first, we got to focus on the classification of these joints. And the first classification is going to be functional, and then we'll focus on structural. So functional is kind of the backbone of all of this, okay? It's going to let us know basically how much movement each of these joints can have. And as you can see, we have different symbols for them. So synarthroses is going to be symbolized S. You see there's no like line surrounding it. It's just kind of a straight up S. There are no lines surrounding it. And because there are no lines surrounding it, that means that we're looking at something that has no movement. Or very, very, very tiny, tiny, tiny movements if possible. And then we have amphiarthrosis, and amphi means both. But we do see a single line around that A. Kind of looks like this. And that's telling us that, yes, there is a little movement here for those particular joints. But again, not it's more than synarthroses, but not as much as diarthrosis. And then with diarthrosis, what do we see? We see symbol this way, and we also see symbol this way, which is saying that this has a large range of movement. Or you can say range of motion. Okay? So that's what we're going to get into, the functional classes of joints first, just to talk about how they move. And then we're going to get into the structural classes of joints, like, for example, fibrous joints. You'll see we have sutures, gomphoses, and syndesmoses. And next to it, you'll see the different types of functional classes of those joints. So sutures should have no movement, gomphoses should have no movement, and syndesmoses has the ability to have a little movement. That's what we see here. And then we have cartilaginous joints, which is going to be synchondroses. Again, it has an S next to it, which means that it's synarthrosis function. That means it should have no movement, whereas the symphyses are going to have a little movement because they have an A next to them. And as you can see, we kind of connect both the S and the A because fibrous joints and cartilaginous joints can have both depending on the type. And then we have diarthrosis, which means it has a larger range of movement. And as you can see, the synovial joints, all the different types of synovial joints have diarthrosis. So that means they're dynamic and they have a wide range of movement. Now I'll put range of motion here, ROM. Okay, now let's talk about it. It doesn't mean that every single type is going to have the same type of movement. Okay, some of them have a little less movement, but overall they have more movement than synarthroses and amphiarthrosis. And what else do we notice? That function is going, or structure is going to dictate function, or really function and structure overlap. So yes, I can figure out the structure of my fibrous joints, but you see their function is going to overlap with whether or not they can move a lot or a little or a large amount. By the way, what joints must solve a design problem: mobility versus stability. Every joint is going to strike a different balance. And that's going to be the most important part. So you can think of joints on a spectrum. Like the more a joint moves, the more engineering it needs to stabilize it, like we saw with a shoulder joint, needing a lot of muscle and ligaments, and of course the overall shape to help. And as we go along, we want to keep in the functional classes. Instead of writing synarthroses, we'll write a capital S. Instead of writing amphiarthrosis, we'll write a capital A. Instead of writing diarthrosis, we'll write a capital D next to some of the actual types of joints that we see here. So now let's go ahead and get into the classifications that we just talked about: the synarthroses, amphiarthroses, diarthroses, and then of course the structural joint classification like fibrous, cartilaginous, and synovial joints. Let's get into the general ideas of those. So joints can be classified by their function, we saw before, and their structure, we saw before. And as we see, one joint can be classified in one of the functional classifications and one of the structural classifications. So we saw kind of how they overlap. Okay. Now let's go ahead and get into our functional classifications. There's going to be 3 functional joint classes based on the amount of movement allowed. We saw that as well. Now, the first 2 we're going to talk about is where you don't have as much movement. So synarthrosis is still or stationary. It's a still or stationary joint with basically no movement. So we call them the immovable joints. Okay. Now, we'll talk a little bit about how they can have a little bit of tiny, tiny, tiny movement as we go along. Okay. But then let's go into amphiarthrosis, and that's a slightly movable joint with a little or average movement. And both of these are often going to be seen in the axial skeleton, but not always. But if you're thinking of in general, they're often going to be in axial. Then we have diarthroses, which are going to be dynamic and freely movable joints that are going to be mainly in the appendicular skeleton. So let's go ahead and get some details about what some of these names mean. We have synarthrosis, and syn means together. So that syn means together, okay? And as you can see, that's going to create still or stationary type of joints which have little movement. Now, it can accommodate a little bit of movement, especially when the skull is growing into adulthood. So you will have like little pieces or pieces of the actual skull itself still being able to kind of have a lot of dense irregular connective tissue within it. But as it gets older and older and older, then of course that becomes like more bone instead of connective tissue. and the synarthrosis, or that is going to make it really, really basically stagnant or strong. And because of that, less movement. Okay? Now, amphi means both. So that means you're going to have movement on both sides. It's only going to be a little movement or an average amount of movement. So let's go ahead and look at our vertebrae here. This vertebrae can move back or it can move forward. Okay? And that means it can move on both sides, but it's not doing this huge amount of movement when we're talking about a vertebrae. Now, if you're talking about your entire spine, that means you're taking all of the vertebrae movements and putting them together, adding them up. That's why your spine can move a little bit more. If we're talking about a piece of our actual vertebrae here, a piece of the spine, then we're just saying it is amphiarthrosis. And then finally, we have diarthrosis. So di means through or across. What we notice is that it kind of gives us a little cone shape here. So it's kind of like you have the point, like this is going to be our shoulder joint here, and then of course towards the distal end, it can actually move in a circle with this particular joint, and that's going to give dynamic and free movement. That through or across, you're saying that it's movement through a joint. So you have like a point of that joint, and then below that joint, you can move. So for example, I have my shoulder joint, and I can freely move my basically hand in a circle if I wanted to. So circumduction, which we'll learn about as we go along. Let's focus on the structural joint classifications. We already know that there are going to be 3 structural joint classifications, and this is going to be mainly based on the binding material used between skeletal elements. So what's going to actually hold these joints together? That's what we're talking about. Fibrous joints, as we know, is going to be strong and stable. So if they're strong and stable, that means they're going to have less movement. Okay, because remember, the more stability, the less movement. The more movement, the less stability. Right? So that's what we're thinking of. And this is going to be bound by collagen fibers of dense connective tissue. And usually it's going to be dense irregular connective tissue, but it can change. So I know they say dense connective tissue in general, but it's going to be way better to have dense irregular connective tissue, because that means you have multiple ways that you're stabilizing that particular joint just by having multiple directions or having no particular pattern to that connective tissue. And they're always going to be synarthrosis or amphiarthrosis, meaning no movement or a little movement. Now let's go ahead and get into cartilaginous joints. Of course, they're going to be bones bound by cartilage, as the name suggests, right? The type of cartilage, hyaline cartilage and fibrocartilage. There is no elastocartilage for these, only hyaline and fibrocartilage. So yes, we know that the hyaline and fibrocartilage are going to be tough yet flexible. So we see a lot of stability, which means less mobility. Okay, folks? So let's keep that in mind as well. And then finally, we have synovial joints, and synovial joints are very specific because they have a synovial cavity. You can also say a synovial space, and also ligaments within an articular capsule, and that's going to be something we learn about as well. So they even look very different. They're not just all of the cartilage, they're not just collagen fibers. They actually have a cavity that's going to help this overall joint and support the joint around it. And they also have ligaments that are surrounding that joint and creating a capsule as well, that we'll get into details as we go along. And because of this synovial cavity or space in between the bones of a synovial joint, they can vary in movement. And that's how we get a lot of different movements, and why a lot of the focus of the overall lecture is going to be movements of synovial joints. You know, the synovial joints are going to always be diarthrosis. So we even see some images here. First things first, we have our tibia and we have our fibula here. And we do have a fibrous joint between them. So again, they're attached by a regular dense connective tissue and collagen fibers, of course, that don't have a specific pattern, so that there is a random arrangement. So no matter how it moves, you always have that ability to have that stability in different directions. Okay? So that's what's cool about the fibrous joints. Cartilaginous joints, as we see here, like we see in our invertebrate disc or vertebrae disc, in between them is going to be our cartilage. Okay? And as you can see, these cartilage here, when you expand it or microscope expand it, then you're going to see that there's a lot of chondrocytes, which we know that's how we are going to be able to distinguish our cartilage. They have chondrocytes between them. Okay? Next, we also have our synovial joints. And number one, what do you see? You see that synovial cavity here. So we have our synovial cavity, and then we also see that we have a capsule, and then our synovial cavity here. And this is the femur and a pelvis. So this is showing our hip joint. Okay? So again, this is just kind of the overall classification of these joints, and we're going to get into details of each individual one next in the next video. So just keep that in mind. See you there.